Now that we've got a handle on how to solve one-step inequalities using addition and subtraction, remember that didn't change the direction of the inequality at all. Now we're ready to tackle something new. So this is section 9.2. Here's the I can statement. I can solve one-step inequalities using multiplication and division. Multiplication and division. Okay, so here's the warm-up, and again, just quick graphing review. This says, again, read from the variable x is greater than 5.5. So I'm going to put 0 on here. I'm going to put 5 here, and I'm going to put 6 about right here, and then I'm going to circle 5.5 in between, and I'm going to go ahead and label that, so 5.5, so everybody can tell what that is. I don't have to fill it in because it just says x is greater than 5.5, not an equal to. So the answers are greater than 5.5, so we're going to shade this direction right here. Again, the two lines, put an arrow on the end, just a little bit of shading there. And that kind of, putting the 5 and 6 there kind of indicates that you know approximately where 5.5 is. So on this one right here, again, this is a fraction. We've done one of these before. It might not be a bad idea to think of this. Okay, this is negative, and then 4 goes in here 3 times. That would be 12, and then 1 left over. So this was negative 3 1/4 for graphing purposes, so we can kind of locate where that is. So we're going to put 0 right here. It's in between negative 3 and negative 4, so I'm going to put negative 4 right here. I'm going to put negative 3 right here, and then again, negative 3 1/4 would be a little bit closer to negative 3 than it is to negative 4, so I'm going to put it right here. And then again, I'll go ahead and label this as negative 13/4. And let me go ahead and zoom in on that one so we can see what's going on here a little bit better. So I'll go ahead and write that a little more neatly. So this is negative 13/4. And then we're going to shade, let's see, again, read from the variable. So the answers are less than or equal to. So we've got to fill this in because it can actually equal that border point right there. And we want to shade less than. So the answers are less than that, so we're going to shade to the left. So go ahead and graph it like that, and we're in good shape. Okay, so we've already established that adding and subtracting when solving an inequality does not change the direction of the inequality. We leave the inequality sitting in the same direction that we found it. If it was a less than before, it's a less than after. Now, can you say why that's true? We talked about that several times in the last section. The reason that's true is all we're doing by adding and subtracting is we're just taking the sides and we're just sliding them down if we're subtracting, or sliding them up if we're adding. So thinking about the number line, adding moves the numbers up the number line, and subtracting moves the numbers down the number line. So to the left would be down, and up would be right. So again, same type of exercise we did before, but this time we're going to be using multiplication and division. So it says put the correct inequality in between the numbers, perform the operation, and then put the correct inequality between the new numbers. So let's go ahead and do this. So negative 2 and 2, that's going to be a less than. Then we're going to times by 7, so we're going to multiply both of them by 7. So I'm going to multiply both sides by 7. Again, using the parentheses to indicate that implied multiplication. Always put it around the second one. So this is going to be negative 14 here and 14 here. And then negative 14 is less than 14, so it goes like that. Okay, next one, 18 and 12. 18 is the bigger one, so I'm going to do it like this. That's 18 greater than 12. We're going to divide by 6, so we're going to divide both sides by 6, and we get 18 divided by 6 is 3. 12 divided by 6 is 2. 3 is bigger than 2, so I'm going to have a greater than. Let's see, 7 and negative 3. The negative one's always going to be smaller than the positive one, so this is a greater than. We're going to times both sides by negative 4, so I'll times that side by negative 4 and that side by negative 4. So we end up with, let's see, negative 4 times 7 is negative 28. Negative 3 times negative 4, negative times negative is positive, so that's going to be positive 12. And now, well, let's see, this one's negative now and that one's positive. The positive one's got to be bigger, so it goes like that. And on this one, we're going to divide by negative, whoops, I forgot to put the symbol in between there. Negative 20 and 35, the negative one's smaller, so this is going to be this way. We're going to divide both sides by negative 5. So let's see, negative divided by negative is a positive 4, and let's see, 30 divided by negative 5, 35, that's going to be negative 7. And then let's see, this one is the bigger one. Okay, what do we notice about the inequalities? Well, on this one it stayed a less than, on this one it stayed a greater than, on this one it switched from a greater than to a less than, and on this one it switched from a less than to a greater than. So we're going to write sum switched direction, and which operation switched direction. Now this is a little bit misleading because it wasn't just an operation. So notice here we have multiplication that didn't change it. Here we have multiplication that did change it. So it's not just the operation. Here we have division that didn't change it, and here we had division that did change it. So which operations, or which ones of these did change directions? Well, it was the two of these right here. It was the ones that involved the negatives. Okay, so it was the ones where we multiply or divide by a negative. Those are the ones that switch the directions, and that's really the key to understanding how to solve inequalities, because these are going to get, we're going to have more steps to solve and different things like that. We're going to have addition, subtraction, multiplication, division, and stuff like that. So here's the key. I want you to put an asterisk by it. I know I already did. I want you to put one there. This is ultra important. We're going to go over this, and we're going to say this numerous times. And in classes in the future, if somebody says, hey, how do you solve an inequality? If you've got a teacher that says that, if you can, rattle off this sentence, you're going to be in really good shape. It is the key idea behind this entire unit that we're doing. So we solve inequalities just like we solve equations. So all the rules are exactly the same, except when we multiply or divide by a negative. That's the only time we have to do anything different, is if we multiply or divide by a negative. So anything else, simplifying, distributing, collecting like terms, anything like that, adding and subtracting something from both sides, totally okay. But if we multiply or divide both sides by a negative, then we switch the direction of the inequality. And what we mean by that is if it was a less than before, we change it to a greater than, or if it was a less greater than, we change it to a less than. So we just change the direction of the inequality. So can you understand why it works that way? Can you say why these two operations, multiplying by 7 and dividing by 6, didn't change the direction, but here when we multiplied by negative 4 and here when we divided by negative 5, why it changed the direction? Well, if you'll remember what negative means, that kind of gives us a clue. Negative means, negative means opposite. So what we're doing is we're introducing the idea of an opposite. Whenever we throw a negative, or multiply by a negative, or divide by a negative in an inequality, it makes the numbers the opposite of what they used to be, the opposite direction from 0 that they used to be. So 7 used to be bigger than negative 3, but when we multiply by a negative, that's going to be the opposite sign. So this one ends up being negative, that one ends up being positive. So they kind of flip directions there. Same thing with this example right here. So let's go ahead and do a couple of examples. I'm going to do 6 of them, and then we're going to go through some key ideas that will set you up for the rest of the unit. So let's go ahead and solve each one of these. It says solve the inequality and graph the solution. So I'm going to make this a little bit bigger so we've got plenty of room here. And let's take a look at example A. So we're going to go through and we're going to solve this. We've got to get the x by itself, so we're going to divide by 5. Now remember, we do this just like we do an equation, except when we multiply or divide by a negative, and you'll notice that we're dividing by a positive. That does not change the direction. So we get x and 7. This stays the same direction. That's it. We're done right there. That's it. So we're going to do 0 on the number line. We're going to do 7 on the number line. I'm going to circle the 7. Do we fill it in? Yes, we do, because of the equal to underneath there. And then again, read from the variable. X is less than or equal to 7. So the answers are less than 7. So the answers are on the left side. So we're going to go like that, and it's that quick. There's our answer to A. Let's take a look at this one. We've got 30 greater than or equal to negative 6r. If you want to read it that way, that's fine. It would be better if we read it the other way. But let's just go ahead and solve it. We don't even need to read it yet. We just need to get the variable all by itself. So let's divide both sides by negative 6 and then stop and think. Are we multiplying or dividing by a negative? We are. So on this side, notice that this becomes a negative 5. On this side, notice that this becomes a positive r. So the original one, the positive one, was over here, the negative one was over here, if you wanted to think of it that way. And now they've switched. The negative's over here and the positive's over here. So I'm going to take that and switch that around. So because we multiplied by or divided by negative, we switch the direction of the inequality. There's our answer. So let's put 0 on here, negative 5. We'll circle the negative 5. Let's see, we do have to fill it in because it can actually equal that. And then read from the variable. The answers are greater than or equal to negative 5. So the greater than side is going to be to the right. Go ahead and fill that in. All right, next one. On C, let's see, we need to get the y by itself, so we're going to multiply this side by negative 10, and we're going to multiply this side by negative 10. Those are going to cancel. That's going to give us a negative 20 over here, and we get a y over there. Now, we multiplied by a negative, so we introduced a negative into this problem. We introduced the concept of opposite. So this becomes the opposite of what it used to be. There's the answers in inequality, but we need to be able to graph that. So I'm going to put 0 right here. I'm going to put negative 20 right here. I'm going to circle the negative 20. We don't fill it in because it's not equal to that. And then we're going to shade, let's read from the variable, the y's are greater than negative 20. The answers are greater than negative 20. So greater than would be on this side. So we'll shade that direction and we're all set. Okay, let's tackle a couple more of these and then we'll talk some more about some of the specifics. So we're going to multiply both sides by 2. Cancel here, so we get y, and on this side we get a negative 20. We multiplied by a positive, and notice this side stayed with a positive sign and this side stayed with a negative sign, so we're going to keep that direction. Multiplying by a 2 doesn't change the direction. So let's see, we've got 0 here, we've got negative 20 right here, and let's see, we're going to circle that. We are going to fill it in, and let's see, the answers are greater than or equal to, so the answers are greater than negative 20, so we're going to shade that direction. And this one, let's see, multiply by negative 4 to get that variable by itself. Let's see, we get a 12 over here. Okay, we did multiply by a negative, so we have to switch the direction of the inequality, so it's going to go like that. We'll circle that answer and then read from the variable. The answers are less than 12. So here's 12. We're going to fill it in. We're going to circle it. We don't fill it in because it's not equal to, doesn't have that little equal to bar there. So the answers are less than 12, so we're going to shade to the left. All right, and last one here, divide by 6. Dividing by 6 does not change the direction of the inequality. Let's see, we can reduce that. 3 goes in here twice, and 3 goes in there actually 29 times, so that would be negative 29 halves. So we'll circle that. We might want to think, let's see, 2 goes in there 14 times, so that'd be negative 14 and a half. So we're going to put 0 here, and I will put negative 15 here and negative 14 here. So negative 29 halves would go right here. So that's negative 29 halves. We are going to fill it in and then read from the variable. The answers are less than or equal to negative 29 halves, so the less than side would be on that direction. So it would look like that. Now, a couple things I want you to keep in mind. Just because there's a negative in the problem does not automatically mean that you switch the direction of the inequality. Some people get caught up in that and say, oh my gosh, the answer is negative, so I must have to switch the direction of the inequality. That's not the case. It's only when you multiply or divide both sides by a negative that we have to switch the direction of the inequality. It's the step that we're taking to solve the inequality that can switch the direction. So let me show you example D and F right here. So you'll notice that on this one, on D, there was a negative in the problem, but what we did is we multiplied by a positive 2. Multiplying by a positive doesn't change the direction. Again, you could kind of think of this side as being positive to begin with and this side of being negative to begin with. It was still positive over here and negative over here, so the direction didn't have to change. Let's take a look at this one. On F, we divided both sides by a positive, and some people will freak out and say, oh my gosh, this answer is negative, I've got to switch the direction. That's not what happens. It's only when we multiply or divide both sides by a negative. It's the step we're taking. Like on this one, we multiplied both sides by a negative. On this one, we multiplied both sides by a negative. So that's what you've got to be careful of. Okay. Let's see. The solution to an inequality is all the numbers that make the inequality true. All the numbers that make the inequality true. So we get that whole range of answers. Anything from the border, including the border, and then to the left would work. On this one right here, the border would not work, but anything over here would work. On B, the border of -5, that would work because that's shaded in, and then anything that's bigger than that would make the inequality true. So if we actually plugged a number back in, picked a test point or something like that and plugged it in, it would make the inequality true. And then another key idea, it's usually best to read the inequality from the variable. If you read from the variable, you're going to be better off in the long run, regardless of whether it's from the left or the right. So keep in mind that thing that we talked about at the beginning. Right here. We solve inequalities just like we solve equations, except when we multiply or divide by a negative. Then we switch the direction of the inequality. Anything else is fair game. Simplifying, distributing, adding and subtracting, all that sort of stuff, totally okay. It's just when we multiply or divide both sides by a negative.